Good afternoon, everyone. Welcome to a Tech Moment on Cannabis Tech. I'm your host, Christina Etter. In this podcast, we take just 15 minutes to talk about some of the innovative science and technology in the cannabis and hemp industries. Today, I'm speaking with Dr. Andrea Holmes, the Chief Growth Officer at Precision Plant Molecules and Professor of Chemistry at Doane University. I met Andrea at CSU Pueblo's ICR conference, and I found her presentation on the use of colorimetric arrays for cannabinoid identification absolutely fascinating. Thank you for joining me today, Andrea.
I'm so delighted to be here. Thank you for inviting me.
Absolutely. Do you want to start by telling us a little bit about your role in this research?
Absolutely. Yes, I'm a professor of chemistry at Doane University, which is located in Crete, Nebraska. And I'm also the Chief Growth Officer at Precision Plant Molecules. So I'm sort of stepping my foot in both areas, the industry as well as academia. And so during my academic career, I developed portable and deployable sensor devices, including colorimetric arrays that are really versatile and can be used for a lot of different applications. So I've been working on that technology for over 10 years and have received some generous funding from the federal government to develop this technology. And because of its broad applications, it has a lot of uses, potential uses in the cannabis industry, which I am working in right now.
Fantastic. So let's start with just this basic overview of using colorimetric arrays. Give us a synopsis of how you create these sensors and how they work.
So these sensors are just so simple, and sometimes simplicity actually takes a lot of work to get sensors that are actually built on very simple concepts. So these sensors that I've developed change color in the presence of a particular analyte, whether that analyte is a drug of abuse or an abused substance or some kind of a contaminant like an environmental contaminant, pesticides. I've had a lot of success with many, many different types of analytes. So because the arrays are sort of a combination of color, in the presence of a particular analyte, the combination of color changes in a very specific pattern. It's almost like a unique fingerprint, like your fingerprint is different than my fingerprint. And so these colorimetric arrays can identify very specifically what type of substance is at play based on the colorimetric changes. The color space is very rich. It's called RGB, red, green, blue. And by extracting these colorimetric changes, this specific signature can identify the substance. And to get this technology to a form where it's really simple, it took a lot of work to figure out how to make them small, inexpensive, and easy to produce, but also to really make them applicable for and customizable depending on what application they're used for. So I decided to pursue a technology that everybody knows, inkjet printing. I mean, you can all go to Office Depot, I shouldn't name any names here, but any office supply store and buy some kind of inkjet printer. And I've worked very, very hard with my students at Doane University to make a very specific formulation on how you can take these color sensors and formulate it exactly so that the consistency, the thickness, and the viscosity is just like the ink that you use in your cartridge in your inkjet printer. Gotcha. And so that's once we had achieved that, we were able to inject our sensors into empty ink cartridges, put these ink cartridges in the printer, and then print the arrays. And so that while it sounds really, really simple, it took a lot of manpower, a lot of hours, and a lot of money to get it down to that simple technology. And so these can be easily printed on a piece of paper, and you can, depending on the application, you choose what type of sensors you are going to put on the piece of paper. see some sensors are reactive towards drugs of abuse, while others are responsive to environmental contaminants or to some kind of steroids that are of interest. So this is the beauty of the technology, where one can custom pick the sensors that are being deposited and printed on the piece of paper.
Wow, that is absolutely some impressive technology. Just to be able to simplify it, like you said, and get it to something as simple as an inkjet printer, you know, something that you might be able to go to any place and buy for $50 or $100 or whatever. So tell me a little bit, that color change process, does that actually detect potency of cannabinoids or just presence? What does that test for?
Mm-hmm. Yeah, so when we first started, we were really just shooting for identification, because, you know, you have to start somewhere. So when we were really successful in the identification of the chemical present, of the analyte present, then we took the next step and said, okay, so now we cannot just do qualitative analysis, we also need to do quantitative analysis. Can we use our technology to determine how much of the analyte is there? So we have done a lot of testing of our analytes at different concentrations, and we use some very nifty technology, software, that then was able to extract these red, green, and blue color values, and they were able to respond depending on the strength of the concentration. So we published several papers on this, where we could actually use our technology and determine the identity of the substance as well as the concentration of the substance.
Wow, that is definitely some impressive technology then. So one of the things that you talked about at the ICR conference was the use of a smartphone application to help identify the color changes. Can you tell us a little bit about that application and where you're at in that development process?
Yes, you know, the ultimate goal is to create a sensor that everybody can use in the field. And typically, you know, if one wants to analyze an unknown substance that is being found in the field, like a US soldier in the battlefield or a police officer looking at a white unknown substance, typically these types of materials are being sent into a lab where a highly qualified technician or scientist has to analyze these samples, and using big expensive equipment with extension cords, power requirements, expensive software, susceptibility to all kinds of fluctuations. But ultimately my goal was, can the regular average person who doesn't have a science background go into a field, take these sensors and analyze them and determine quickly, do I have to flee? Do I have to get out of this zone because I'm in danger, or am I okay? It's like a triaging. And so, you know, everybody that I know of, even my parents, they all know how to use the camera on a phone. So I thought, we need to figure out a technology where just your smartphone can capture the image of the array, and then the software tells you exactly, oh, okay, this analyte is an explosive. I better get out of here. And I'm basing that on the fact that smartphone technology, the camera in there, they are now so sophisticated and can recognize, you know, where's the center of your face. Or even the software, when you deposit a check, right? It recognizes right away. If the signature isn't there, then it doesn't get deposited. So that sophistication in itself lends it perfectly to use that and take a photo of the array and get the result right away for anybody who wants to use the technology. But here's the thing: so I developed this code in collaboration with a company that was located overseas. But, you know, due to some limited funding that I had to develop a code, a very sophisticated code for smartphone technology and recognition of patterns, cost a lot of money. And so I had a limited amount of funding. I hired this company overseas, and the code that was written for the software was what they call dirty, meaning it wasn't a clean, nice code that would render it as an easy application. Also, because it was a foreign company, it wouldn't really lend itself to be suitable for the US government, for the US Army to use in their applications. So bottom line is I have a code, it's not very good, and that needs to be developed further with more funding.
Gotcha. So clearly this application has uses in law enforcement, in schools, and in different areas like you talked about in overseas with war applications, things like that. Let's talk about some of these applications that you foresee using these colorimetric arrays. Could these potentially detect the toxins and contaminants in, say, hemp crops, or help farmers, maybe kind of identify those hot hemp crops that are too high in THC before they actually go to market?
Yes, exactly. So this was my whole motivation of going to Denver, to investigate whether I could use this technology and make a customized cannabis detection system. And so I started out using different matrices and tested the sensors with these different matrices, including I used concentrates, marijuana concentrates, as well as flour and topicals, creams. And I was able to identify some really, really good sensors that were able to change color in the presence of these cannabinoids. And because I have never tested the arrays for cannabinoids before, so with this technology, it's kind of at the infancy right now, while my other analytes, like warfare agents and drugs of abuse, that is almost like ready. In fact, there are several companies right now that are looking at licensing that technology for their purposes. But the cannabis part of it, I literally just started that late last year, and I've already gotten some really great results. But that is a project that has to be further investigated. Preliminary results are really, really promising. But if I am continuing to have the same success with cannabis as well with the other analytes that I have published many, many papers on, then I should be able to identify the different types of cannabinoids, quantify the different kinds of cannabinoids, and then take it a step further and take all of the different pesticides that are regulated in the various states and identify those types of contaminants. One thing that the array might not be very suitable for is the detection of biologicals, such as yeast and molds and things like that, structures. And so the colorimetric arrays are really chemical sensors. So they detect smaller molecules, not big conglomerates of proteins and things like that. Once the technology is there, that, wouldn't it be great, say in the hemp industry now with the farm bill, anything over 0.3 is considered hot, and therefore you got to destroy the whole crop. So it would not be great if a farmer could test along the way instead of having been told by the Department of Agriculture, oops, no, if the farmer could monitor him or herself, okay, I'm getting hot, I better do my harvest right now. So I think that would be really lucrative. And, me being at a cryoethanol extraction facility right now in Denver, one really important application that I foresee also is because a lot of extractors for cannabis and marijuana, they're using solvents like hydrocarbons, butane, propane, ethanol, and the people that are working in these types of environments, they're basically exposed to a lot of different types of organic solvents. So wouldn't it be great if we could have a sensor that an employee just wears and realizes, oh, wow, I am being exposed to a lot of pentane here. Pentane is used to do a lot of crystallization in the cannabis industry to isolate CBD and etc. And so these molecules are not particularly good for you. So if you could monitor yourself for any kind of exposure, or if your boss, says, hey, let me see your badge, I want to make sure that you're working in a safe environment. So developing sensors that can prevent any kind of hazardous exposures for extraction companies. And that's very close to my heart, since I'm working at Precision Plant Molecules, where we do use a lot of organic solvents to extract the hemp components. So the applications are just, it never stops talking about it. You can think of so many things. I have one company right now, a big, very big one, that I can't list their names due to confidentiality, but they're one of the biggest crop players in the United States, in the world actually. And they have gotten such great results on 2 sensors on testing their seed for stability. And so seed stability is another big market in not just the cannabis industry, but all over the agricultural world. So, the applications of this technology is just endless.
Obviously, we're always going to have the need for detection, so for your kind of technology, the colorimetric arrays, whether it's legal or not legal, detection is still a major portion of the technology that's going to be needed even after regulations in place. So good for you on what you're doing. And Andrea, I can't thank you enough for joining us today for this podcast, and how much fun it's been talking with you, and how much I enjoyed meeting you at the ICR conference, and good for you on what you're doing.
Yes, and please tell your audience to reach out to me at any time. I'm pretty visible on the web. Just put in Andrea Holmes, Precision Plant Molecules, or Andrea Holmes, Stone University. I'm on Facebook. I'm pretty visible, so I'm happy to talk and discuss